Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is July 22nd, 2025. This video is on a Nature Reviews cardiology article published on 27 June 2025 titled Tailored Therapeutics for Cardiomyopathies. Understanding disease basics. What is the current challenge in treating cardiomyopathies? Most therapies address symptoms, example heart failure, cardiac arrhythmias, but not the underlying molecular or genetic causes. Tailored therapies aim to correct the root biological dysfunction, example sarcomeric mutations, calcium handling defects. How are cardiomyopathies classified? There are five main phenotypes: hypertrophic cardiomyopathy, dilated cardiomyopathy, non-dilated left ventricular cardiomyopathy, restrictive cardiomyopathy, and arrhythmogenic ventricular cardiomyopathy, right ventricular cardiomyopathy. Based on ventricular structure and function, each has distinct pathogenesis with potential genetic contributions. Which genetic mutations are most common in hypertrophic cardiomyopathy? Pathogenic variants MYBPC3 and MYH7 account for 70% of sarcomeric mutations. Hypertrophic cardiomyopathy may be also polygenic or mimic storage or infiltrative disorders. What are myosin modulators and how do they work? Agents like myosin-10 and FESM10 stabilize beta-myosin's super relaxed state, reducing hypercontractility, ATP use, and LVOT obstruction in hypertrophic cardiomyopathies. What evidence supports gene therapy in cardiomyopathies? Early trials, TN201, RPA501, show promise. Strategies include gene replacement, RNA interference, and base editing. Genetics and phenotypes. What are the novel metabolic modulators under investigation? Paraxylene, trimetazidine, ninarfaxat, and SGLT2 inhibitors improve myocardial energetics by shifting substrate use to glucose or ketones. How does calcium handling go awry in cardiomyopathies? SERCA2 cardiac dysfunction, PLN mutations, and altered calcium channel kinetics lead to calcium overload, contributing to dysfunction and arrhythmia. What is the role of inflammation and fibrosis in disease progression? TGF-beta and NF-kappa beta activation causes fibrosis and apoptosis. Arrhythmogenic right ventricular cardiomyopathy and DSP-related dilated cardiomyopathies often show inflammation-driven heart phases. Are therapies specifically for Fabry or amyloidosis? Are there therapies specifically for Fabry or amyloidosis? Yes, Fabry, ERT and migalastat. Amyloidosis, RNA inhibitors and stabilizers like tafamidis, addressing lysosomal or protein misfolding pathologies. How does gender influence cardiomyopathy presentation and therapy? Men with dilated cardiomyopathy are far worse. Women with hypertrophic cardiomyopathy present later with more fibrosis. Hormones modulate inflammation, ion channels, and calcium kinetics. Precision pharmacotherapies. How does lifestyle influence disease expression? Intense exercise accelerates disease in PKP2 and LMNA carriers. Healthy BMI, blood pressure control, and avoiding alcohol are essential. What are the major barriers to implementing precision therapies? Key hurdles include limited access to genetic testing, regulatory complexity, trial design for rare variants, and therapy cost. What distinguishes non-dilated left ventricular cardiomyopathy from dilated cardiomyopathy? Non-dilated left ventricular cardiomyopathy has normal LV dimensions but regional dysfunction of fibrosis, often associated with desmosomal mutations, example DSP. What's the role of desmosomes in arrhythmogenic right ventricular cardiomyopathy and non-dilated left ventricular cardiomyopathy? Desmosomes provide mechanical and electrical stability. Mutations lead to inflammation, cardiomyocyte detachment, and fibrofatty replacement. How does myosin-10 improve obstructive hypertrophic cardiomyopathy? It reduces LVOT gradient, improves symptoms and NYHA class, lowers NT-proBNP and troponin with sustained remodeling benefits. Molecular mechanisms and trials. Are there therapies for non-obstructive cardiomyopathy? Mafesamtan in Maverick hypertrophic cardiomyopathy trial and afisamtan in Acacia HCM trial lower biomarkers and improve symptoms. Ongoing trials explore long-term outcomes. What gene editing tools are being explored? CRISPR-Cas9 base editors and ASOs target MYH7, phospholamban, PKP2. Early models show gene correction, reduced fibrosis, and improved function. What are RASpathies and their link to hypertrophic cardiomyopathy? Syndromes like Noonan involve RAS MAP kinase mutations. Tremetinib improves LV hypertrophy and NT-proBNP, modifying disease in early onset cases. What's the significance of mitochondrial dysfunction? It causes ATP deficit and oxidative stress common across hypertrophic cardiomyopathy, dilated cardiomyopathy, and HFpEF. Therapies aim to restore energy metabolism. Why did ranolazine and trimetazine fail in trials? Despite solid mechanisms, trials showed no clinical benefit in hypertrophic cardiomyopathy, possibly due to sample size or poor endpoint sensitivity. Future direction and monitoring. What's unique about phospholamban p-arginine 14 deletion? This founder variant causes malignant dilated cardiomyopathy, non-dilated left ventricular cardiomyopathy. It severely disrupts calcium handling and is a target for gene therapy and antisense oligonucleotides. How is Denon disease being treated? RPA501 gene therapy restores LAMP2B expression and improves cardiac structure and function in early phase trials for severe cardiomyopathy. What are the limitations of gene therapy? Immune reactions, transient expression, and off-target effects limit use. Is less effective in late-stage disease and fibrosis. Are there markers to monitor therapy response? NT-proBNP, troponin, imaging, T1 time, LV mass and fibrosis, and cardiac MRI. And arrhythmia burden are key for tracking disease progression and treatment impact. How should trials evolve for these therapies? Use genotype-specific stratification, adaptive design, surrogate endpoints, and real-world data to capture rare variant outcomes. If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by Master MedFacts at mastermedfacts.com.